Okay, Wildcat, today we're looking at journal page 42, quadratic formula and the discriminant. To solve a quadratic function, the function is set equal to 0. The solution to the quadratic functions are the x-intercepts, also called the roots and or zeros. There are three types of solutions to quadratic functions. 1, 2 real solutions, 2, 1 real solution, and 3, no real solutions, complex number or imaginary solution. There are three algebraic ways to solve a quadratic function. 1, factoring, 2, completing the square, 3, quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac, a times c, divided by 2a, where d is a discriminant, which is equal to b squared minus 4ac. Now the discriminant tells us one of three possible things. When d is greater than 0, there's two real solutions. When d equals 0, there's one real solution. And when d is less than 0, there's no real solution, where d represents the discriminant. There are two ways to check the solutions. 1, graph. 2, use a table. Okay, if you would complete your notes. Now your notes are completed. Let's take a look at the examples. Okay. Solving quadratic functions using quadratic formula, including complex roots. Find the zeros of each function using the quadratic formula. Let's go ahead and write down now to reference on each examples. So x equals negative b plus or minus the square root of b squared minus 4 times ac divided by 2a. All right, example 1. F of x equals x squared plus 10x minus 2. First thing we're going to do is define what a, b, and c are. So that's 1, that's your a. So a equals 1, b equals 10, and c equals negative 2. Okay, now we're going to substitute those values into the quadratic formula. So that's x equals, now that's negative b, so negative 10 plus or minus, and I'm going to use here so you can see the difference between what I'm writing and the lines. Square root of 10 squared minus 4 times a is 1 times c is negative 2 divided by 2 times 1. Okay, so x equals, I don't think I need to use black pen on everything, just where the division line probably is. So that's a negative 10 plus or minus, and then the square root of, now 10 squared is 100 plus a negative times negative, so that's 8. So 100 plus 8 is the square root of 108 divided by 2. Now, we need to figure out what the discriminant tells us. So let's take a look at here. I think I drew that a little too far. Okay, so the discriminant. Well, we know the discriminant equals 108, which is greater than 0. Now, from our notes, we know that when the discriminant is greater than 0, we know there's two real solutions. Okay, so now with that, we know as we solve this, we know that we're going to have two real solutions. Now, we need to simplify the square root. So we need to find a perfect square that divides into 108. Okay, so let's look at that. Okay, so let's try 108 divided by 4. That's a perfect square. Okay, so that works. But let's see if we can go bigger. Okay, now the next perfect square is, let's see, 2 squared is 4, 3 squared is 9. So 108 divided by 9. Oh, so we can go even bigger. Okay, so now let's see if we can go even bigger. So let's see, we know that the next perfect square is 16. So 108 divided by 16. That doesn't work. The next one is, that was 4 squared, 5 squared, 25. So 108 divided by 25. That doesn't work. The next one is 6 squared, 36. So 108 divided by 36. That's as big as we can go because I don't think you're going to get any smaller than 3. So now we know that 36 times 3 is 108. Okay? So now we can write this as x equals -10 plus or minus the square root of 36 times three divided by 2. Now, when you take the square, you can now take, when you multiply underneath the square, you can take the square root of each term individually. So x equals -10 plus or minus the square root of 36 times the square root of 3 divided by 2. Okay? So now, I think we need to add an extra line here to have space for one more step. So then that's x equals -10 plus or minus the square root of 36 is 6 times the square root of 3. I don't know why I just put the 3 in black, but that's fine. Divided by 2. Okay? So now that's x equals -10 divided by 2 is -5 plus or minus 6 divided by 2 is 3 square roots of 3. Now, remember I said that we have 2 real solutions. Well, that's 2 solutions. We have x equals -5 plus 3 square roots of 3, and x equals -5 minus 3 square roots of 3. So either way is acceptable, right? You can write it this way as your solution, or you can write it separated this way as your solution. Okay? All right, if you would finish up example 1. All right, now let's take a look at example 2. Okay? So first thing first is we want to say A is 2, this is 1, so B is 1, and C is -10. Okay, now we're going to substitute each of those values into the quadratic formula. So x equals negative 1 plus or minus the square root of b, so that's 1 squared minus 4 times 2 times negative 1 divided by 2 times 2. Okay, so then that's x equals negative 1 plus or minus the square root. Well, 1 squared is 1. Oh, wait a second. Almost made a mistake. That's a 10, so that's negative 10. And that's why you want to be careful when you're doing your work. Look for little mistakes like that. Okay, well, negative 4 times 2 is 8, negative 8, but negative 8 times negative 10 is a positive 80, plus 1 squared is 1, so that's 81 divided by 4. Okay, well, this problem becomes simple because we know the square root of 81 is 9, so this is x equals negative 1 plus or minus 9 divided by 4. So x equals negative 1 plus 9 divided by 4, which negative 1 plus 9 is 8, so it's 8 divided by 4, which equals 2. Okay? So there's one solution. Okay? Now, let's go back because we got 1. Let's check with the discriminant. So the discriminant we know is equal to 81, which is greater than 0. We know if the discriminant is greater than 0, we have 2 real solutions. You always want to check with the discriminant to know how many solutions you should get. Okay. Now we know that we have 2 real solutions. We also need to know that we need to do x equals negative 1 minus 9 divided by 4, which that's negative 10 divided by 4, which we know reduces to negative 5 divided by 2. So there's our 2 real solutions. Okay, go and finish up example 2. All right, let's take a look at example 3. Now, before we do anything else in this example, we need to add 9 to both sides. Whenever you're solving the quadratic formula, everything needs to be on the left side. Okay, when we do that, we have 1x squared, excuse me, minus 6x plus 9 equals 0. So a equals 1, b equals negative 6, and c equals 9. Now we're going to substitute those values into the quadratic formula. So x equals negative 6 plus or minus the square root of, now whenever you square negative, it needs to be in parentheses. So negative 6 squared minus 4 times 1 times 9 divided by 2 times 1. Okay? So x equals a negative times a negative is a positive, so that's 6 plus or minus the square root of, now that's 36 minus 4 times 9 is 36, so that's 36 minus 36, which is 0. Okay? Divided by 2. Well, the discriminant equals 0, and we know when the discriminant equals 0, there's one real solution. Okay? So that's x equals 6 plus or minus 0 divided by 2. Well, that's x equals 6 plus 0 divided by 2, which equals 6 divided by 2, which is 3. Okay? And then we have x equals 6 minus 0 divided by 2. Well, that's still just 6 divided by 2, which is 3. So we, in essence, really have only one solution. X equals 3. But there's something special about this. Because we got 3 twice, we say that x equals 3 with a multiplicity of 2. Okay, so go ahead and finish up example 3. All right, let's take a look at example 4. Okay, so everything's on the right side. So then we know that A equals 2, B equals -1, and C equals 2. Okay, so then that's X equals, that's a -1 plus or minus the square root of -1 squared minus 4 times 2 times 2 divided by 2 times 2. So x equals a negative times a negative is a positive 1 plus or minus the square root of, now negative squared is 1. 1 minus 4 times 2 is 8. 8 times 2 is -16. So this is 1 minus 16, which is -15 divided by 4. Okay, well, let's look at the discriminant. The discriminant equals -15, which is less than 0, and we know when the discriminant is less than 0, there's no real solution. Okay. Now, we want to see if there's a perfect square that divides into 15 to reduce that. So let's try 15 divided by the first square is, perfect square is 4. That doesn't work. And the next one is 9. 15 divided by 9. As you can see here, there's no perfect square that reduces 15. Now, the next thing here is we need to kind of understand what the square root of a negative number is. So let's just put that in. So let's do control square root of -15. And you can see here it says a non-real calculation. Okay. And so the way we write a non-real calculation solution is we write that as imaginary. So this is x equals 1 plus or minus the square root of 15 I. We're saying that's an imaginary solution divided by 4. So our two non-real solutions are x equals 1 plus or minus, and you can actually write the I in front if you like, I squared root of 15 divided by 4, and x equals 1 plus or minus I. Oh, what am I doing? I'm sorry. We're separating it. So 1 plus, if I can get this plus sign right, plus and minus I square root of 15 divided by 4. Now, you can write your solution like this, and that's acceptable. Or you can write your solution separated like this. Okay? So you can either write your solution like this, or you can write it as x, the 1 plus or 1 minus. Okay? All right, with that, if you would finish up your examples and start working on your assignment, and have a wonderful Wildcat day.